Okay, so today we're going to look at tangent lines. We're going to do some sketching of tangent lines, finding the slope at a particular x value, writing equation of tangent lines, and then looking at where would the tangent line be horizontal on particular graphs. So let's start with sketching the tangent line at the indicated values. So a tangent line is going to go through just one point on that graph. So let's first start with x equals 4. So I go to my x equals 4 on the graph, and what I want to do is create a line that passes through just that one point. And that is going to represent the slope at that particular point. So I know if I extended it, it would pass through more than one, but we're just looking at that particular part right there. So then when I'm trying to sketch the tangent line at x equals 2, that's at the bottom of a parabola. We know that's where the slope equals to 0. We saw this when we did some graphing stuff. So there's our tangent line. At -4, it's going to be right here. And then drawing that, it falls like that. Okay, so that's just sketching some tangent lines. Let's try this on another example. So here at x equals 1, it's through that, it goes through that one point. And there's my tangent line. At x equals 3, I go to 3, I put a point, and then my tangent line falls like that. Maybe not so horizontal. Let's do a little bit. And then at -1, we're looking right there. Okay, so that's just some practice sketching. You go to the x value, put the point on the graph, and then you can just sketch your little line. Okay, when it comes to writing equations and doing slope, if we are trying to use a point, we have to use the original function because it's all about a point on that graph or in that function, so you've got to reference the original. Slope, we always have to use the derivative. That's the purpose of the derivative, to find the slope at a particular x value. So for this one, it says find the slope of the graph at the given point. So we're going to find it at x equals 2. Well, I first have to take the derivative of this, and then I can use that to find the slope. So I'm going to rewrite this so that it's x to the -1. Okay, taking the derivative of this, derivative of x is just 1. Here I bring down the negative and make that -2. So here's my derivative. I'm going to plug into the derivative because that will tell me the slope when x is 2. So 1 minus 1/4, the slope is going to be 3/4. Okay, let's try another one. Find the slope of the graph at this given point. Again, to find the slope, I got to do the derivative. So the derivative of this, the derivative of cosine is negative sine. So that's going to turn that into -2 sine x. The derivative of -5x is just -5, and then the derivative of 3 is just 0. So, to find the slope at x equals 0, I plug in 0 for x. Evaluating sine of 0 falls right here. Sine is all about the y. So sine of 0 is 0. 0 minus 5, our slope is -5. Okay. Equations of tangent lines. We always write these in point slope form. The slope we're going to get from the derivative. The point is from the original function, f of x. Slope is from f prime of x. So, find the equation of the tangent line at the given point. Okay, so to write the equation for a tangent line, we need a point on the line and we need the slope. So let's first find a point. We know We need our point and we need our slope. With the point, I know my x value is -1. I need to find my y value. That is a point on the original function. So we have to use f of x. So I am plugging in -1 into f of x. To find my y value of the point. So this becomes -2, that's 1 times -3 is -3, minus 1 plus 4. When I work this out, I end up getting -2. So the point is -1, -2. So that's a point on f of x. So just like we were doing here, we use that point to go through our tangent line. So it's a point on the original function. Okay, so now I got to find the slope. That means I need to do the derivative of this function to find the slope. So taking the derivative of this, I get 6x squared minus 6x plus 1. Just going term by term. Okay, I am trying to find the slope at x equals -1. So I have to plug in -1 into this function and simplify. So this ends up being, and this will give us our slope, 6 plus 6 plus 1. Our slope is 13. So we have our point and we have our slope. I put it into point slope form. There we go. Let's try another one. So same thing, finding the equation of the tangent line. Again, we need a point and we need the slope. This is the x value of the point. To find the y value, I plug it into the original. We just found sine of 0. That's 0 plus 1 equals to 1. There's our point on f of x. To find the slope, I got to do the derivative. Okay, the derivative of sine is cosine, and then the derivative of 1 is just 0. So to find the slope, I plug in 0 for x. We know at 0, cosine is all about 1, is all about the x. So the slope is 1. So y minus 1 equals 1 times x minus 0. There's our equation of the tangent line. Okay, now we're going to move on and determine the points where the tangent line is horizontal. If you are horizontal, that means your slope equals to 0. So how we do this? I am going to start by taking the derivative. So if I take the derivative of this, I get that equation. I am going to set the derivative equal to 0 because that's saying, okay, where is the slope equal to 0? Because you're setting the derivative equal to 0. I'm going to start in GCF. I get here, that's a difference of perfect squares. So we have 3 x values where this function has a slope of 0. So at x equals 0 from there, at x equals 2 and -2. The question is determining the points. We said that anytime we're talking about points, we got to go back to the original function. So I'm going to take these and I'm going to plug in 0 to the original function and find the y value. So I'm using this function. I make x equal to 0. That ends up giving me y equals 2. So one point on the graph where it is horizontal is at 0, 2. Then using this x value, I plug that in. So I end up getting 16 minus 32 plus 2. I end up getting -14. So that's my y value. So 2, -14. Then I'm going to do negative 2. So y equals negative 2 to the 4th minus 8 times negative 2 squared plus 2. So this ends up giving us the same value for y. So this is negative 2, negative 14. And there are the 3 points on this graph where our function has horizontal slope. Okay, let's try this last one. Just like we did before, we need to take the derivative. So the derivative of cosine is negative sine x. The derivative of a constant is 0. I set my derivative equal to 0 to find out where is the slope 0 so that it's horizontal. Divide by negative 1, 0 equals sine x. I'm going to rewrite this. Okay, solving this equation, I put this over a number. This can be a quadrantal. So sine is y over r. So where is y equal to 0? At 0 and pi. Okay, so we have two x values where it is horizontal. It's asking for points. So I got to kind of plug in 0 and pi to the original f of x. So I'm doing f of 0 and I'm doing f of pi. So cosine of 0, that's weird, I have a graph right here, is equal to 1. 1 minus 1 is 0. So this is 0, 0. Pi, cosine at pi is negative 1, minus 1 is negative 2. So it's pi negative 2. Okay, and those are the 2 points where this function, where the tangent line will be horizontal.